Data centers have been around for quite some time. It's basically a collection of highly interconnected servers that deliver massive processing power. The rise of generative AI resulted in a very accelerated demand for data center capacity. The same search on Google versus ChatGPT, it would be an order of magnitude, about like 10 times more energy. So there's more utility in the latter, but it comes at the price of much more computational intensity and therefore much higher power consumption to get there. This whole power consumption challenge, on one hand, is a headwind for how the Gen AI is being adopted. On the other hand, it creates enormous opportunity for the chip developers who actually solve this problem.
Data centers support a wide range of critical products and services across the economy. According to various estimates, electricity demand from data centers could grow anywhere from 10 to 20% a year through the end of this decade, which would make it one of the fastest growing periods in modern history.
Microsoft is building this Stargate data center based on the budget that they announced, which is $100 billion. If you just do the math, if you assume how much GPUs you can buy for this money, and knowing the power consumption of every GPU, we're looking at 5, 6, 7 gigawatts per hour of power consumption, which is unheard of in terms of the scale of how much a single data center could consume. That amount of power would be enough to power millions of homes.
When we think about the growth in electricity demand from data centers and AI, there's really no perfect solution. You have all of these tech companies that have significant decarbonization ambitions, and they have this surging demand for electricity. So ideally, they would meet the incremental demand using just solar and wind. The problem with solar and wind is that they are intermittent.
Case in point.
Yeah, case in point. But to solve the problems of intermittency that solar and wind bring, we need energy storage. Energy storage adds cost to the system, which makes it somewhat less competitive, and it also doesn't necessarily provide enough duration. We're hearing these companies kind of expanding their aperture for what kind of carbon-free energies they're looking at. They're looking now at nuclear and hydropower, but those also have issues. So that kind of leaves fossil fuels, which make up the foundation of our energy system today, primarily natural gas. There is ample supply of natural gas to meet incremental demand from both data centers and AI. Part of what we're seeing, in addition to solar and wind additions, natural gas additions, is the push out of closures of existing plants. So that could be coal plants in the US or Europe. Could also be nuclear plants that were planned to close. So there's a friction for these companies between meeting their decarbonization goals and their internal growth goals.
There will be no simple solution. There will be multiple efforts coming from multiple entities in the supply chain that hopefully will achieve the goal of delivering the service and not completely violating the environmental commitments that have been made. In terms of data centers themselves, they can certainly try and run them more efficiently, but it inevitably brings us to the point of more efficient equipment. And that puts a lot of pressure and creates opportunities for semiconductor companies that power those servers. Schneider Electric or Delta, they create modules and systems that deliver the power, control the power, transfer the power, but they are using chips which are manufactured by companies like Infineon or Silergy, who design those power management integrated circuits, or PIMICs. Those are the chips that, unlike logic or memory, only control, distribute, and convert the power. Logic processors, companies like Intel, NVIDIA, AMD, they develop efficient architectures where they can get more processing power delivered in a smaller power envelope. The memory chip makers like Hynix and Samsung and Micron, they try to deliver more efficient memory chips that would give you more storage capacity, better bandwidth, and it all comes on a smaller power budget.
Some of the tech companies are working with utilities to shift their loads both in time and in space. You can think about a data center processing more of their compute loads during the afternoon when the sun is shining and solar power is plentiful. Or you could think about a utility shifting more loads regionally to an area where the sun is shining. So maybe we use more of our data centers in Spain on a sunny day in Spain, or in Norway if it's windy there. And in that way, we can help to balance out the grid and sort of reduce these incremental stresses that are coming from this new demand.
One of the challenges in solving this problem is that all the players across the entire food chain would have to deliver, from power generation to power distribution, to how the power is actually used in the data centers, to how the new chip architectures are being able to deliver more processing power on a smaller or same power envelope.
As an energy analyst, AI is exciting. It has, I think, a lot of potential to improve corporate efficiency, to improve margins. There is a lot of uncertainty in how this could play out. And at the end of the day, it's going to come down to what customers and consumers demand, which will dictate the company's strategies.
If there is a serious failure or failures across the food chain and we don't have enough power, what's going to happen is that the power prices will go through the roof, and that will make AI services completely uneconomical. There will be no AI revolution. We'll go back to caves and I remain optimistic that given the trajectory of the development and the cadence of innovation, it will be truly a revolutionary technology.